Okay, so let's continue looking at real-life examples of parabolas. Here, this example, we have a cannonball shot horizontally from the top of a cliff. Its path can be modeled by the relation, and they give you the equation right there. So I'll just highlight the equation that they give us. Okay, h is equal to -5 t squared plus 150, where h is a cannonball's height above the ground, and the units are meters, and t is time, and the units there are seconds. So here we're going to use the equation to get our information. How high is the cliff? Well, to find how the height of the cliff, the cannonball is shot horizontally from the top of the cliff. So the cannonball, to find the height of the cliff, we're going to put t is equal to 0, the initial height. And then we're going to sub it into our equation. So h is equal to -5. And then we plugged in 0 for t plus 150. Okay. And now we're just going to do some number crunching there. So 0 squared is 0. So -5 times 0 is 0. So h is equal to 150. Okay. So therefore, height of the cliff is 150 meters. And again, it's the initial height of the cannonball, hence why we put t is equal to 0, because it's the initial height. All right. What is the vertex of the parabola? So there, normally we see something in brackets, right? The h values in brackets. You're not seeing an h value there because the h value is actually 0. And the k value is 150. So normally, you're used to seeing the equation like this, right? So in this case, this is -5 and x, and the h is 0. I'm just showing you. Okay, so that's the same equation, and then what we would do is simplify it to get the equation that they give you in the answer there. So -5, and then they use t instead of x, so -5t squared plus 150, and they used h instead of y. Okay, so the vertex there is 0, 150. What is the maximum height reached by the cannonball? Well, remember the maximum height is they're talking about the optimal value. Optimal value, which is the y value of the vertex. Okay, so what is the maximum height reached by the cannonball? That is 150 meters. Okay, and when does it reach its maximum height? It actually reaches its maximum height at t equal to 0. Okay, so when it's actually first launches, when it's actually going to reach its maximum height, because the vertex, remember the vertex here is 0, 150. That's the max height, and that is the time for the max height. Okay, what is the cannonball's height after 2 seconds? All right, So here they're saying if t is equal to 2, what is h? Well, we got the equation. So what we're going to do is we're going to sub in 2 in place of t. Okay, so we're going to sub in 2 in place of t. Again, do some number crunching. This is -5. 2 squared is 4 plus 150. So -20 plus 150 is 130 meters. Okay, so therefore the height after 2 seconds is 130 meters. How long was the cannonball in the air? Round your answer to the nearest tenth. Okay, so here what we're going to do, so they give us a little bit of a hint there. It says when the cannonball hits the ground, its height is 0, right? So remember the cannonball is being shot off of a cliff, 150 meters above the ground. And then its path is coming down and it's eventually going to hit the ground. Okay, so when h is 0, what is the time? Okay, so again, we have our equation. Let's just write down our equation. Plug in 0 for height, right? Because when it hits the ground, it's going to be 0. And now we're going to isolate for t. So again, we're going to bring the 150 over the equal sign. So it's going to change its sign. So it becomes -150. Okay, divide both sides by -5. Okay, so -150 divided by -5 is 30. T squared. And now we got to take the square root of 30 to get t. And remember, you're going to get we're going to get a decimal answer because 30 is not a perfect square. So make sure you have your calculator or use a decimal. And the square root of 30 is, and we're going to round it, is 5.47. So we're going to round it to 5.5 seconds. Okay, so therefore the cannonball is in the air for 5.5 seconds. All right, and there you have it. Hope that helped.